This episode describes the Generalized Growth Balance Method. As we have said before, Module 3 has 3 episodes and 3 annexes. This module provides information that will help you intuitively understand the logic behind the Generalized Growth Balance or GGB method for evaluating population and death recordings coverage in census data. This method uses data from 2 censuses. If you want additional information about the estimations using the Generalized Growth Balance method, please see Annex 1 in this module. To achieve our goal, first I will present the assumptions behind the GGB method. Next, I will define the data requirements. Please make sure you have this data ready for the country or area you are analyzing before you start using the workbook. Then, I will explain the logic behind the GGB method and estimation of adjustment factors, which are based on the population balancing equation and intercensal growth rates. I will also briefly present an application and its interpretation. To complete the episode, I will also cover how to adjust mortality rates using the adjustment factors. We conclude the lesson by sharing checks and validation strategies, as well as caveats and reminders. At the end of this episode, please make sure you take the time to answer the learning assessment. Before deciding on the use of an evaluation method, it's always important to ask ourselves about the assumptions behind the method and if our data and country population dynamics meet these assumptions. The GGB method has 4 assumptions. First, reporting of ages in census data is reasonably accurate. Second, the recording of deaths and population does not vary with age, at least over age 5 years. Third, deaths as recorded have the same age pattern as did deaths during the entire intercensal period. Please note that only if mortality is not changing will the estimate reflect actual coverage in the census reference period. Fourth, the population is closed or little affected by migration. To apply the GGB method, you should have the following tabulations from 2 censuses less than 15 years apart. Population by sex and 5-year age groups, deaths by sex and 5-year age groups, and maternal or pregnancy-related deaths by 5-year age groups. The Generalized Growth Balance method uses population counts from 2 censuses to estimate age-specific growth, entry, and death rates, and estimates relative completeness of census coverage and death recordings for the interval between 2 censuses. The main difference with the brass growth balance method described in episode 1 is that the GGB method does not assume a stable population model. In other words, the GGB method does not impose the same growth rate for all age groups. Growth balance method rests on the idea that by applying the growth balancing equation, we can compare the observed age distribution of deaths with the implied age distribution of deaths from the age distribution of the population and estimate an adjustment factor. The identity of the general balancing population equation also applies to open-ended age intervals. From the balancing population equation, we have that the generalized growth balance method incorporates age-specific population growth rates for the intercensal period using data from 2 consecutive censuses. The estimation of the adjustment factor is based on the difference between the true and observed patterns of age-specific death rates. The true pattern assumes age-specific death rates implied from the balancing equation, and the observed age-specific death rates are calculated from the deaths in the first census, the second census, or the average intercensal deaths. In a nutshell, the GGB method assumes a discrepancy between the true pattern that we are not observing, but that is implied, based on the age pattern of deaths estimated from the balancing equation, and the observed age pattern of deaths that might be undercounted. There are 4 steps to the estimation of adjustment factors. All these steps are included in the workbook. We are explaining them here to facilitate your understanding, use, and interpretation of results you will obtain from it. Step 1. Estimate entry, death, and growth rates for open-ended age segments. Before I list the next step, let's review the logic behind them. In an unstable population unaffected by net migration, the entry rate into each open-ended age segment is equal to the true death rate for that segment plus the actual growth rate of the segment, as shown in slide 10. Alternatively, if we rearrange the equation, the entry rate minus the growth rate will equal the true death rate. Because it is the product of a difference, we call it residual death rate. Now that we know what is the residual death rate, in step 2, you estimate it as the difference between entry and growth rates. Now let's continue with the logic behind the third step. If deaths are incompletely reported, that true or residual death rate will be equal to the observed death rate multiplied by an unknown factor S. This relationship can be expressed as a straight line relationship between the residual estimates of the death rate and the observed death rates, with intercept I and slope S. Then, the third step to estimate adjustment factors is to run an orthogonal regression on residual and observed death rates. Plot the residual death rates against the observed death rates and fit a straight line using orthogonal regression. Make sure to exclude points at the ends of the age distribution that appear out of line. Once you have estimations of I and S from the orthogonal regression estimated in step 3, in step 4 you will find the population coverage K1 and death reporting completeness C. To do that, let's look at the constant I and slope S of the linear equation. Compare the equation at the top with the equation at the bottom. We indicate the relation of the intercept I to measurements of census coverage and the relation of the slope S to the adjustment factor for death recording from census data. I, the constant, is the estimation of the change in census coverage, and the slope S is the inverse of the completeness of death recording, I over C, times the geometric mean of the coverage factors for 2 censuses. The intercept I of the fitted line estimates the constant error in the growth rates, or the coverage of the first census relative to the second census. This can be calculated at the exponentiated intercept multiplied by the intercensal interval, where K1 is the completeness of the first census and K2 is the completeness of the second census. The values of K1 can be obtained from the above equation by assuming that K2 is equal to 1. The completeness of reporting of deaths relative to population is estimated from the slope S of the straight line fitted to the series of points. S is a ratio of the geometric mean of census coverage and the adjustment factor for death coverage. Once you estimated K1 relative to K2 in the intercept, you can also estimate the completeness of death recording C. Again, we are explaining the mechanics behind the calculations, so you have an understanding of estimation procedures. However, you do not need to program or do any of these estimations by hand. The workbook includes all calculations and provides values for K1, K2, and C. Hill and others applied this method to a number of countries. Here we show their example using data from the 1999 and 2009 censuses of Vietnam. We can see that the fit of the data is very good. All points are aligned closely to the fitted line. The results indicate that the completeness of death records is 68%, and the completeness of the second census in relation to the first census is 99.55%. In the example using data from Vietnam, it's clear that we do not need to make any adjustment to the choice of points. For example, omit points for the older open-ended age intervals. However, If the points do not align to the fitted line, you as the researcher will need to take some decisions regarding the selection of points. If the country you are analyzing is exposed to net migration, then select the open-ended intervals between age 30 and over and 65 and over. Otherwise, accept wide uncertainty in the adjustment of population and death recordings. For example, in this case, points are not aligned. There is a lack of consistency by open-ended age segments. Now that you know how to estimate relative census population coverage and coverage of death recordings, here we show how to use K1, K2, and C to adjust age-specific death rates and pregnancy-related deaths. To estimate adjusted age-specific death rates, we multiplied observed age-specific death rates by the ratio of the geometric mean of the coverage rates for both censuses to the death recording adjustment factor C. Pregnancy-related deaths are adjusted by multiplying the number of deaths of women ages 14 to 49 that occur within 6 weeks of termination of pregnancy or delivery, regardless of cause of death, by the inverse of the death coverage factor, 1 over C. To make sure that your analysis is consistent, you can apply the GGB method to male deaths and compare with the results for female deaths. Census coverage rates as well as death recording rates should be similar within a range. You should also compare the results from two different methods, GGB and synthetic extinct generations method or SEG, which I will cover in the next episode, and is available in the workbook. You could also look to available indicators of mortality for your country. For example, UNICEF publishes country-level data for maternal mortality online, or the Demographic and Health Survey reports for your country. If completeness of death recordings is less than 60%, then the uncertainty of your indicators is substantial, and you should consider this when writing your report. Results from this method are sensitive to substantial levels of net migration. If you are applying this method at the subnational level for regions or districts, and the levels of internal net migration for any of these geographical units is large, then you should incorporate age-specific net internal migration rates to the estimation. You will need net migration by sex and age for each geographic unit. Internal migration is not uniform at all ages. If retirement migration to rural areas, as well as age exaggerations patterns are present in your data, consider omitting death rates for all ages from your estimation procedure, as this might bias your result. If you have data from only one census, use the Brass Growth Balance method. It is not recommended to use the Generalized Growth Balance method with survey data. To close this episode, we offer a comparison of the two growth balance methods we have covered, the Brass Growth Balance method in episode 1 and the Generalized Growth Balance method or GGB in this episode. If you have data only from one census, you should use the Brass Growth Balance method. If you have data from population by age and sex from two censuses and data on deaths from the first or second census or from both censuses, you should use GGB. Adjusted measures of mortality will be estimated in the workbook according to the data you have available. Please answer true or false to the following two statements. First statement, the GGB method is based on the assumption of a stable population. Second statement, the advantage of the GGB method is that it incorporates observed growth rates from two censuses to estimate relative completeness of population records and completeness of intercensal death records. Here are the answers for the previous questions. First statement, the GGB method is based on the assumption of a stable population is false. There are no assumptions about how long a population has observed the same birth, death, and growth rates. The assumptions of the GGB method are: reporting of ages in census data is reasonably accurate. Recording of deaths and population does not vary with age. Deaths, as recorded, have the same age pattern as did deaths during the entire intercensal period, and the population is close or little affected by migration. Second statement, the advantage of the GGB method is that it incorporates observed growth rates from two censuses to estimate relative completeness of population records and completeness of intercensal death records. Is true. Results from the GGB method provide a relative census completeness factor and a factor for death coverage. Both of these indicators by sex.